Okay, today we are doing notes number 8, and today's notes are on dividing exponents. So we're going to start right away with the quotient of powers. So here's our first problem. 5 to the 5th divided by 5 to the 3rd. I want you to think about really quick, just like before, just take a really quick guess. What do you think 5 to the 5th divided by 5 to the 3rd might be? Well, this one here, if you try to do something like 5 divided by 3, that would be very difficult. So let's figure out how to do this. Well, we know we could rewrite this as a fraction, which would be 5 to the 5th divided by 5 to the 3rd. Now, using our expanded form that we've learned before, we know that 5 to the 5th is really 5 times 5 times 5 times 5 times 5. And 5 to the 3rd is 5 times 5 times 5. Now we're allowed to split these into all different fractions. So if you think about individually, we're doing 5 divided by 5, 5 divided by 5, and 5 divided by 5. So when we do 5 divided by 5, we get 1. And then we do the next 5 divided by 5, we get 1. And these are multiple. 5 divided by 5, we also get 1. Times 5 times 5. Well, we know when we're multiplying by 1 here, 1 times 1 times 1 times 5, that would just be 5. So therefore, this really equals just 5 times 5. And if we were going to put that in exponential form, that would just end up being 5 squared. So all of this was just 5 to the 2nd power. Because when you divide the same number by itself, it really just goes away. So therefore we had 2 5s left, so 5 squared. Now this was a lot of work to do. There is a shorthand way of doing it. If you go back and look at our exponents, 5 and 3, imagine if you just subtracted those. So if we just did 5 to the 5th minus 3, just subtracting the exponents, we get 5 squared. That's because these 3 here, get rid of 3 of them here, and we have 2 left over. So, hopefully you understood all that. Let's go back and look here. To divide powers with the same base, make sure we know it's the same base, just subtract their exponents. Subtract over and keep the base the same. Very important. Okay, so that's all you got to do is subtract exponents. So if we look over here, if you look, the bases are the same and we're dividing, so you would keep the base the same and subtract the exponent. This is just a formula saying whatever x is and whatever y is, you simply subtract those, always in the order of the first minus the second. So let's try some problems. Alright, so just remember what we said, this will be pretty easy. We are going to express each product in exponential form. Remember, we need a base and an exponent. So we could see we have the same base, so we keep the base the same. We are dividing, therefore you just subtract the exponents, 12 minus 3, and that would simply be 2 to the 9th. That's it. Okay, on question B, again we have the same bases. So again, keep the base. And remember, we're going to subtract the exponents, always first minus second, or if we look back at this one, it's always the top minus the bottom. So remember that. So therefore, this would be just 3 to the 5th. Again, pretty simple, hopefully, for you. Okay, I think we got a couple more. Okay, now this one is a little more involved, but you could see that we have like bases here and here. We have like bases here and here. And finally, like bases here and here. So all you have to do is and subtract those ones. So if we look at our 4s, it would be 5 minus 3. And if we look at our negative 5, make sure you use parentheses like we learned before. Our exponents are 4 and 3, so that would be 4 minus 3. And finally, we have to look at the 6. Now, the 6 is a little more tricky because some people might think, well, there's nothing to subtract right here. Well, remember, we learned that if a number does not have an exponent, then you should insert a little 1 there. Don't forget that, because some people will not subtract 3 minus 1. They'll just leave it 3. So our 6's will be 3 minus 1. Therefore, just do your subtraction. This would be 4 to the second power times negative 5 to the first power times 6 to the second power. And that would be your answer. Okay, let's try one more. Okay, now this one's a little more difficult. As you could see, we do not have like bases, so we can't subtract any exponents right now. Don't think you could just put a 1 here and do 12 minus 1. The bases are not the same. But remember, we try to look for hidden exponents. Therefore, we know that 25 is really 5 times 5, and therefore that is really 5 squared. So we could change that 25 into 5 squared, and now it would look like 5 to the 12th divided by 5 squared. Now we have like bases, so we could subtract the exponents, 5 to the 12th minus 2, and you just get 5 to the 10th. There we go. So remember, if you do not have like bases, see if somehow you could transform one of these into an exponent so you do have like bases. Okay, hopefully you just learned something, so please hit pause, try all 4 of them, and see how you do. All right, let's see how you did on these. We have like bases, so we got to subtract the exponents. Don't forget that you should have put a 1 right there, so that would just be 12 to the 7 minus 1, which is 12 to the 6th power. Okay, number 2, again, we have like bases, so that would be 5 to the 9 minus 8, which is 5 to the first power. Now 5 to the first power is the exact same thing as 5, so this is probably how you would see the answer written if it was on a test. If you leave it as 5 to the first, you won't get it wrong. You'll just see it written more as just 5 though. Okay, let's look at the next 2. Alright, this is a long one, but all you have to do is line up the like bases. So we have the 7s, we have the negative 3s, and we have the 11s here. Okay, so you just have to subtract their exponents. 7 to the 15 minus 5 times negative 3 to the 10. Don't forget that this one has a 1 right there. Sorry, that came out looking weird. So it'd be 10 minus 1. And finally, we'd have 11, 8 minus 2. Let's do subtraction, so we get 7 to the 10th times negative 3 to the 9th. Times 11 to the 6th. Hopefully that's what you got. And this last one. Okay, notice we do not have like bases. So can we change those to like bases? Well, 9 is 3 times 3, which is 3 squared. So therefore we have 3 to the 7th, 3 squared. Subtract 3 to the 7 minus 2. I'll bring it down here. That would be 3 to the 5th power. So hopefully that's what you got. All right, let's keep moving on. Okay, now we're going to work on some word problems, and notice it says that we want to express each product in standard form, meaning multiply it all out. We don't want an exponent in our answer if we could help it. All right, so let's read the problem. Hawaii's total shoreline is about 2 to the 10th miles long. New Hampshire's shoreline is about 2 to the 7th miles long. About how many more times longer is Hawaii's shoreline than New Hampshire's shoreline? Any word problem, we want to make sure we know what the question's asking. It says it right here. About how many more times longer is Hawaii? Now, how many more times longer is a tricky phrase and something you're going to see a lot in this class. So I'm going to make a small little example over here to help you understand what it means when we say how many times greater or how many times. So imagine this is me right here. Here I am. And imagine that I am 6 feet tall. And next to me is my younger daughter, who is only 2 feet tall. And I simply asked you, how many times greater am I than my daughter's in height? And if you would say 4, because you tried to subtract, that would be incorrect. Think about when I say how many times greater, I mean how many times would my daughter equal me if we stacked her up? So how many of these would work? There's 2 and finally 3, because each of these are 2 feet high. and I was 6 feet tall, so therefore I am 3 times greater than my daughter, or 3 of my daughters would have to be stacked up to equal me. So when you see this term, how many times or how many more times, that really means division. So how many times, you should write this down, equals division. Some people will think this is subtraction and they'll get it wrong if you just try to subtract them. So how many more times, how many times greater, you'll see those phrases come up quite a bit. So now we're saying how many times longer is Hawaii than New Hampshire. So really what that means is Hawaii, I misspelled that, divided by New Hampshire. I'm just going to abbreviate it out. So what is Hawaii's shore length? That is 2 to the 10th divided by, and New Hampshire's was 2 to the 7th. Now we know we have, we're dividing, so we just learned that you subtract the exponents. That would be, 2 to the 10th minus 7, which is 2 to the 3rd. However, remember, the problem said standard form up here. So we're not going to leave it as 2 to the 3rd. We have to multiply that out. We know in expanded form that this would be 2 times 2 times 2. And we would just multiply this and we get 8. So our answer is that Hawaii is 8 times greater. Not like 8 miles longer, but 8 times greater. There we go. Okay, so now I'd like you to try this one on your own. Read through it, take your time, go back to the last example if you need to. All right, hit pause and try it. All right, let's see how you did. Basically, this is talking about sound and how it's measured. We have ordinary conversation, just when you're talking, is about 60 decibels or a 10 to the 6th loudness. That's how they measure it. Thunder, we got thunder now, is 120 decibels, or look, 10 to the 12th. So I know there's a lot of numbers in here, but we've been working with exponents. It's just saying that this 60 is the same thing as this 10 to the 6th. So let's use this one here for conversations, and 120 decibels, or 10 to the 12th. So those are our two exponents. Just where you're working with exponents, we're going to use those. Now, it says right here, how many times greater? Oh, we just learned that how many times means division. So basically, what are we dividing? The thunder divided by the ordinary conversation. So thunder was 10 to the 12th. You just have to go back and look for that. And the ordinary conversation was 10 to the 6th. Okay, so make sure you go back and read the question and see if you can pull that information out. Now we know we have like bases. So we just have to subtract their exponents. 10 to the 12th minus 6, which is 10 to the 6th power. We want this in standard form, so 10 to the 6th would be 10 times 10 times 10 times 10, 10, let's say 1, 2, and 6. Now, I'll give you a shortcut. When you multiply by 10, count up the zeros. 1, 2, 3, 4, 5, 6. So this is just going to be a 1 with 1, 2, 3, 4, 5, 6. So basically, thunder is 1 million times louder than just an ordinary conversation, so it's quite loud. All right, there we go. Hopefully you guys got all that, and I'll see you tomorrow in class.